In this video, we are going to talk about the quotient rule, specifically how to evaluate a derivative using the quotient rule. So essentially what that is if we have a function that takes the form y at x equals f at x divided by g at x, its derivative would take the form y prime at x equals f prime at x times g at x minus g prime at x times f at x divided by g at x squared. So to see how this works in action, we're going to do an example where we have a function, let's say h at x is equal to 2x plus 3 over x squared. So as we can see here, that this right here, let's call this f at x. Okay, and let's call this right here g at x. Then we can evaluate this derivative using the quotient rule here. So essentially you would use the quotient rule to evaluate a derivative if there is if it takes this form here, if there's a numerator and there's a denominator. So let's go ahead and evaluate that. So h prime at x is equal to f prime at x, which is the derivative of the numerator, and that will just be 2 times the denominator g at x, which is x squared, minus the derivative of the denominator, which is 2x, times the numerator, which is 2x plus 3, and then we divide that by the denominator squared, x squared squared. Of course, we can continue and simplify this. So we would write this as 2x squared minus 4x squared. So we're multiplying these two numbers here. 2x times 2x, we'll get 4x squared minus, okay, negative 2 times 3 is negative 6. Okay, 6x. And then we divide this by x to the power of 4. Okay, so x squared squared is just x to the power of 4. And of course you can simplify this even more. What we can do is we can, we'll say, so these two right here, we'll collect these two terms. 2x squared minus 4x is equal to negative 2x squared minus 6x divided by x to the power of 4. And then from here, what we can do is we can factor out an x. So you'll go, we'll say x here, negative 2x minus 6 over x times x to the power of 3. Okay, of course these x's cancel out and we are left with just this here. So x minus 6 over x cubed. All right, and that would be the answer for that derivative. So let's do one more example here. Let's say that we got. Okay, let's do another example. All right, so let's say we got this function here. Let's say we have y at x equals x squared minus 2 over sine x. How do we evaluate that? Well, we will we'll call this f at x here. And let's call this g at x. So again, the process for evaluating the derivative will take the exact same format. So it's going to be the derivative of the top times the bottom minus the derivative of the bottom times the top divided by the derivative, or sorry, divided by the bottom squared. So y prime at x is going to be equal to the derivative of the top, which is 2x. Okay, so 2 times x, and then this just goes to 0, times sine x minus the derivative of the bottom. So the derivative of sine x is just cos x times the top, which is x squared minus 2 divided by the bottom squared. And simplifying this will give us 2x sine x minus cos x times x squared minus 2 divided by sine squared x. And that is our answer. All right, so that's how we use the quotient rule to evaluate the derivative of a function.